Okay, not all quadratic equations have real number solutions. So if I were to look at a graph, if a parabola crosses the x-axis in two places, that quadratic equation has two solutions. Quadratic equations can also have one solution when the vertex is the only thing on the x-axis. If something like this happens, that parabola does not touch the x-axis at all, so there are no real number solutions for that particular quadratic equation. There are, however, imaginary solutions. So if I were to take this equation, x squared equals -1, what number times itself gives us a negative number? I. There isn't an actual real number that you can multiply times itself to give you -1, because a positive times a positive is a positive, a negative times a negative is a positive. So to multiply a number times itself and end up with a negative, that is not possible using the real number system. But in math, there are times when we need to be able to take the square root of negative numbers, so they came up with imaginary numbers. The imaginary unit I is defined as, and you'll need to fill this blank in, I equals the square root of -1. So up until now in math, if they ever asked you to do the square root of a negative number, you would have written no solutions, because it's impossible to take the square root of a negative number. But now we're going to be able to do something with that negative and get an answer, even though it's not a real number answer. An interesting thing happens if we take I and square it. If we square I, we are taking the square root of -1 and squaring it. The square root and the square are going to cancel each other out, leaving us with simply -1. So in the second blank, note that I squared equals -1. We'll get into complex numbers in a minute, but let's use this newfound knowledge to simplify square roots of negative numbers. Anytime you see a square root of a negative number, I want you to break it into the square root of -1 times the square root of the positive version of that number. So -1 times 81 is -81. So we just took that negative and pulled the negative out. The square root of -1 is the imaginary number I. What's the square root of 81? 9. So our simplified radical is 9i. You always write the real number portion first and the imaginary portion last. Number 2, we would first split this into the square root of -1 times the square root of 56. Then think about how could we split up 56? Using our perfect squares, how could we split up 56? 56 divided by 25 is a decimal. 56 divided by 16, I believe, is a decimal. 56 divided by 9, decimal. 56 divided by 4 is 14. So I have the square root of -1, the square root of 4, and the square root of 14. What is the square root of -1? I. Square root of 4, 2. Square root of 14, we can't simplify that anymore. We have these three things, I, 2, and square root of 14. The correct way to write this is 2i square root of 14. Number 3 is just like number 2, except that there's a negative 7 in front. So we've got negative 7, the square root of negative 1, and the square root of 12. What could we split that 12 into? Square root of 4, square root of 3. Okay, we've got negative 7 is just kind of chilling in front. What is the square root of negative 1? I. What's the square root of 4? And the square root of 3 stays square root of 3. Do you see how I color-coded those? What do you think the answer is going to be, the final answer? Negative 14I times the square root of 3. Complex numbers. If you look up at the top of the page, or towards the top of the page, it says a complex number written in standard form is a number a plus bi. You always put the real part first and whatever is with the imaginary part last. So number 4, if it's addition, the parentheses really don't matter. The parentheses are just saying, here's our first complex number, negative 1 plus 2i, and here's our other complex number, 3 plus 3i. Add those two complex numbers together. This, seriously, is just combining like terms. I acts the same as an x would. So, negative 1 can be combined with 3 because they are both real numbers. What is negative 1 plus 3? 2. 2i and 3i can be combined because they are both imaginary numbers. What is 2i plus 3i? 2 plus 5i. That's it. That's all. It seriously is that easy. Now, if it's subtraction, you do need to watch out. Because we are saying that we are doing 2 minus 3i. We are subtracting the 3. We are also subtracting the negative 7i. What is minus a negative 7i? Plus 7i. So really, we need to take this subtraction and distribute the subtraction to turn this into an addition problem where we can just combine like terms. Once you've distributed the negative, we have 2 and negative 3, which makes negative 1. We have negative 3i and 7i, 4i. So in number 6, which I'm going to let you try on your own, notice you're going to have to distribute the subtraction in front of 3 plus I, but then don't do anything to the 2 minus 3i because there's addition in front of that complex number. So take a moment and see if you can figure out number 6 on your own. If we distribute that negative, we have 2i minus 3 minus I, and if you want to put a 1 in front to help you, that's minus 1i, and then plus 2 minus 3i. The real number pieces, we've got negative 3 and positive 2, so negative 1. And then we've got 2i, negative 1i, and negative 3i. Is that negative 2i? Yep. And it is important that you always have your answer look like a plus bi or a minus bi. You want the I part to be at the end, the real number part to be at the beginning. Okay, now we added and subtracted with complex numbers, so next we're going to multiply with complex numbers. One thing that we need to remember here is that I squared equals negative 1. So make sure you write that in there. I squared equals negative 1. But really, this I acts exactly the same as an x would. There's just one tiny little catch at the end. So 5i times negative 2. Anyone want to take a guess? Negative 10i. 5i times I.
5i squared.
5i squared. Now we need to remember this little tidbit about I squared. I'm going to take this 5i over here, or 5i squared. I squared is the same as negative 1. So this term really says 5 times negative 1. So really, this is a negative 5. So I could cross this whole thing out and put negative 5 in its place, because 5i squared and negative 5 are the same thing.
When you redo the thing, the negative
so you'd have to rewrite it, negative 5 minus 10i, because you need the real part first and the I second. Okay, number 8, we have to double distribute. So 7 times negative 1 is negative 7. 7 times 2i, 14i. Now distribute your negative 4i. Negative 4i times negative 1 is positive 4i. Negative 4i times 2i, negative 8i squared. Okay. What I typically do is I just circle this term and then think about, okay, this is actually negative 8 times negative 1. So really, this term is a positive 8. So you can kind of do that work off to the side. Or some of you are going to pick this up and say, oh, negative 8i squared, that's positive 8. You know to take the opposite of it. So we have positive 8 and negative 7. Those are like terms. Positive 8 and negative 7 would combine to give us 1. And then 14i and 4i combine to give us 18i. Okay, flip to the next page. Try number 9 on your own. Distribute your 2, distribute the 3i. Remember that negative 6i squared is negative 6 times negative 1, so it's really a positive 6. Negative 12 and positive 6 is negative 6. Negative 4i, negative 18i is negative 22i. We are going to do number 10 tomorrow, but I do want to draw your attention to this extra example that I wrote in here. What if it was something like 2 plus 3i, that quantity squared? What does that mean? That means 2 plus 3i times 2 plus 3i, and then you treat it exactly the same as you did in number 9. So I just want you to remember that when you see an exponent on the outside of a binomial like that, you have to write the binomial twice and then double distribute just like we did in that example.